Hello, I'd like to talk to you about natural selection and how that relates to the idea of allele frequency. Allele frequency is how often alleles for a certain trait are found in a population. So with our hypothetical population of butterflies, we have alleles that give us black butterflies that aren't eaten very often by birds, say because it gives them camouflage and they can't see them. And then you have alleles that give a red phenotype to these butterflies that are very conspicuous to birds and they get eaten very often. So alleles for a trait that gives increase in a population allele for coloration because these butterflies don't get eaten as often because they are black in color. Alleles that don't give a survival advantage decrease in a population over time, like the red phenotype, because they get eaten more often, and therefore they don't get to pass on these alleles to the next generation. They may get eaten before they get a chance to mate. And therefore, because they aren't reproducing more often as a population, then the homozygous recessive genotype, these alleles, don't get passed on to the next generation and they become less frequent in the population. Now I can illustrate how allele frequency works using Punnett squares. Remember, Punnett squares show us how across individuals, how the alleles separate out and become the genotypes for the next generation. So here we've got a cross between two homozygous recessive individuals that have the red coloration. And if we do the cross, we find that all individuals that have become butterflies from this cross all have the red phenotype. And therefore, it's likely that none of these offspring will survive to mate themselves. Okay. Then we have a cross between two heterozygous individuals, and it gives us more of a mix of phenotypes. We get genotypes. And find that 75% of the offspring have the black phenotype because they all have the dominant allele for the black coloration. And therefore, more of these offspring are more likely to live and mate and have offspring of themselves and continue to pass on that black dominant gene in the population. And over here, we have a cross between a heterozygous individual black phenotype and a homozygous red phenotype. And in this cross, we get a more varied genotype as well. And in this cross, we see that roughly, 50% have the dominant gene for the black phenotype, and 50% have the genotype for the red phenotype, and therefore 50% aren't likely to survive to pass on that recessive allele in the population. So this just shows that in this population of butterflies, the allele that causes red coloration, the recessive allele, becomes more and more rare as butterflies mate and the red ones get eaten by birds, become conspicuous, and this causes the dominant allele to become frequent in the population. And that is allele frequency, how it relates to natural selection.